Good afternoon, one and all. Once again, I welcome you all for the afternoon session of 4th day of CPE program, which will be conducted by our faculty team, Dr. Habibur Rahman, Professor, Department of Pharmaceutics, Dr. S. Malati, Associate Professor, Department of Pharmaceutical Analysis, Mrs. R. Nitya, Assistant Professor, Department of Pharmaceutics. Over to you, ma'am and sir.
A great presentation takes in people's memories forever. The question is, how do you make an engaging, memorable impact of presentation? How? Whether you are speaking 10 people or 10,000 people, you need to have an icon, that is presentation sparks. Myself, Dr. S. Malati, Associate Professor, Department of Pharmaceutical Analysis. Today, I'm going to share insight of presentation ideas to give a killer presentation. Let's start. These are the few oral presentation ideas. That is, save the best for last and first, change the modalities, create interactivity, get creative with color, work the stage, use vocal variety. First, we'll see the idea number 1. Save the best for the last and first. The very important first thing we have to do for the preparation of the slide is to write down all our ideas, points, and examples. The most of the presenters make a mistake for their innovation. They present in middle of the presentation. This is the huge mistake. Why means most of the people, they remember first and last part of the presentation. This is called serial position effect. So make sure that you start and end your presentation with your best ideas or points. For one idea, use one per slide, use one idea. It is easy to move your presentation ideas around. Use different color for different themes. Then idea number 2, that is change the modalities. People retain only 10%. See the condition, only 10% of the information they received in the spoken presentation. So the presentation contains spoken, not only spoken, visual, interactive. So we use every 3 presentation slide, use one visual slide that makes the audience to understand the concept most clearly. Then idea number 3, create interactivity. Your presentation should not be monotonous in manner. It should be in interactive manner. So for this interaction, we use some icebreakers, then raise your hand questions. Then coming to the idea number 4, get creative with color. We always associate certain colors with certain environment and moods. So it is important to align the colors in your presentation with your message. For one thing, you have to use throughout the presentation. For particular theme, we have to use the same color. Then idea number 5, that is work the stage. The stage is your muse. So if you command your stage, it's look like you have command of your material. Then coming to the idea number 6, that is most important point, that is use vocal variety. Vocal variety is nothing but change the pace, volume and cadence. This is nothing but change your speed, volume and the frequency of the speaking. Then experimenting with different volume and speed. That is always warm up your voice before getting onto the stage. This will help you to use more vocal variety. So you know your stuff and you practice more. So more compatible with your material, better you present. So with this, I conclude my session. Let's watch one video, how the presenter using different vocal variety. This ideas useful for the rapid fire, 5 minutes rapid fire presentation, oral presentation.
Mechanics, we wouldn't have modern physics, we wouldn't have any chemistry, we wouldn't understand so much, we wouldn't have all the technology, we wouldn't be talking about AI because we wouldn't have computers, because we wouldn't have silicon chips, because we wouldn't have understood what a semiconductor is and how electrons move through material. So underpinning so much of modern technology is quantum mechanics. The problem is, you see, that I've highlighted the nanometer. A nanometer is a billionth of a meter. That's the scale where quantum effects start to kick in. That's also the scale where we're dealing with the building blocks of life. Molecules like.
Now I hand over the session to the presenters.
A warm afternoon to everyone, and my topic is about rDNA technology. I am Pratisha. These are the topics I'm going to follow in the following PDF. The history. The picture I have shown is Mycobacterium tuberculosis. The first emerging of the recombinant DNA technology is followed with the history of Mycobacterium tuberculosis in the Egyptians. The 4,000-year-old Egyptian mummies have helped to unravel the mystery of the origin of tuberculosis. This notion was questioned in 2003 when it was reported that a third of 85 mummies examined from Upper Egypt were infected with an Asian strain of Mycobacterium tuberculosis. The best hypothesis is that tuberculosis arose in Africa from an ancestor of Mycobacterium africanum. Subsequently, an Mycobacterium africanum-like strain left Africa with the migration of Asian populations. This was found later by polymerase chain reaction. The amazing archaeological work was made possibly by polymerase chain reaction. Then some of the techniques used as in recombinant DNA technology, which is the field revolutionized by the polymerase chain reaction. The introduction about rDNA technology. The most important application of molecular genetics in biotechnology is genetic engineering or recombinant DNA technology. The genetic engineering is the process of producing an organism that contains a gene or genes not naturally present in that organism. The recombinant DNA technology have been used in the production of many proteins or the other biologics such as human insulin, interferons, interleukins, human growth hormones, and so on. The following three slides includes the strategies or the most important factors that we are going to use in the production of some of the products by using recombinant DNA technologies. One of the first breakthroughs leading to recombinant DNA technology was the discovery by Werner Erber and Hampton Smith in the late 1960s of bacterial enzymes that cut double-stranded DNAs. These enzymes known as restriction enzymes. These enzymes have the specific DNA sequence for their activity. Each restriction enzyme has its own sites. The enzymes are obtained by various microorganisms. For example, from Escherichia coli, the enzyme which is obtained from Escherichia coli is called as EcoR1, which is isolated by Herbert Boyer in 1969. Then the DNA ligase. It is the important strategy that is used in the recombinant DNA technology. The fragments of DNA that can be cut can be rejoined by sealing or ligating enzyme called as DNA ligase. Mertz and Davis in 1972 demonstrated that the cohesive end of cleaved DNA molecules can be covalently sealed with the DNA ligase, and it produces recombinant DNA molecules. These DNA ligase enzymes are originally isolated from the virus, and they also occur in some bacteria and the eukaryotic cells. Then the cloning vectors. There are many types of cloning vectors that can be used in the recombinant DNA. Cloning vectors are the DNA molecules into which the foreign DNA can be inserted for the cloning purposes. The vectors has the ability to self-replicate, integrate into the host cell, then it will replicate among themselves. The target DNA is inserted into the specific sites of the vector and ligated by the DNA ligase enzyme. Some of the examples for vectors is plasmids. These are the extra chromosomal, self-replicating, double-stranded circular DNA molecules, which is present in the bacterial cell. These are found in bacteria and also in some eukaryotes. They have a high copy number and possesses the antibiotic resistance gene. For example, PBR322 is the first artificial vector developed by Bolivar and Rodriguez in 1977 from the bacteria Escherichia coli. This have the origin of replication for the antibiotics tetracycline and the ampicillin. Bacteriophage, these are the most efficient vectors than plasmid for the cloning large number of DNA inserts. These are viruses that infect bacterial cells by injecting their genetic materials either by DNA or the RNA. For example, phage lambda and phage M13 are the commonly used bacteriophages, which are obtained also from the bacteria. Other cloning vectors includes the yeast vectors, cosmids, retroviral vectors, and human artificial chromosomes. There are common 4 steps in the gene cloning. First, isolate the DNA to be cloned from the specific region in the organism. Use the restriction enzyme to generate the fragments of the isolated DNA. Generate a recombinant molecule by inserting DNA fragments into a cloning vector. And the final step is introduce the recombinant molecule into the new host, which expresses the gene. Now, how the insulin is produced by the recombinant DNA technology. First, the introduction of insulin. Attempts to produce the insulin by recombinant DNA technology was started in late 1970s. The basic technique consisted of inserting a human insulin gene and the promoter gene of lac-operon on the plasmids of the bacteria Escherichia coli. Human insulin is one of the smallest proteins secreted by the beta cells of islets of Langerhans of pancreas, which catabolize glucose in the blood. It is used for the patients suffering from diabetes mellitus. Insulin was first derived using recombinant technology from Escherichia coli in 1982 for the human use. Insulin have 2 polypeptide chains, A and B, which is linked via bisulfate bonds. Polypeptide chain A have 21 amino acids and the chain B has 30 amino acids. The steps for the production of recombinant insulin includes the insulin was easily produced by recombinant DNA technology from synthetic gene or from the mRNA separated from the rat pancreas. The chain A and B gene are separately inserted into the plasmids PBR322 by the side of beta galactosidase gene. The recombinant plasmid are separated, transferred using Escherichia coli cells in a culture medium which have the high rich in lactose, and they have specific proper proteins and optimized the physical conditions. The presence of lactose in the medium induces the production of insulin chain A and B in separate cultures. The so formed chains A and B are obtained from removing from the beta galactosidase through the cyanogen bromide. Then the chain A and B are joined by sulfonating the two peptides with the sodium disulfonate and sodium sulfite to form the full-fledged human insulins. The second generation human insulins. After injecting the insulin, the plasma concentration of the insulin rises very slowly. And for this reason, insulin injection has to be done at least 20 minutes before a meal. Further decrease in the insulin level, exposing to the patients to the danger of hyperinsulinemia. All this is due to the existence of therapeutic value of insulin as a hexamer, which degrades slowly to the biologically active monomer and dimer. This second generation insulins are produced in the recent years by site-directed mutagenesis or protein engineering. These products are also called as mutants. A large number of insulin mutants have been constructed with an objective of faster degradation of hexamers to the biologically active forms. Insulin Vispro is prepared by the modified amino acids at the position of 29 and 30 of the B chain of insulin. The protein insulin is different from the human insulin in just one amino acid at the C terminal of B chain of human insulin. The scientists have developed the various methods to alter the chemical structure of protein insulin to make it similar to the human insulin. The modified protein insulin can also be used for the treatment of diabetes mellitus. And the conclusion, it was in July 1980, 17 human volunteers were for the first time administered recombinant insulin for the treatment of diabetes at Guy's Hospital, London. It worked well, and this gave hope to scientists that DNA technology could be successfully employed to produce substances of medical and commercial importance. An approval by the authorities for using recombinant insulin for the treatment of diabetes mellitus was given in the year of 1982. In 1986, Eli Lilly and company received the approval to market the human insulin under the name of Humulin. Thank you.
Hello, good afternoon to one all. I am Srignesh and I am talking about cloning vectors. Cloning vectors. The vectors plays two main roles. That is carry foreign DNA fragments from outside of the cell into a host cell, and inside the host cell it replicate independently and independently. There are various types of vectors, that is plasmids, bacteriophage, cosmids, artificial chromosome vectors, and shuttle vectors. Plasmids are extra chromosomal, that there is presence of a chromosome in a higher number. Then double stranded, there will be presence of two strands like RNA like that. In circular means the shape in circular, then it will be self-replicating DNA molecules. Then size of the plasmids varies from 1 to 500 kilo base pairs. Then plasmids are subdivided into 4 categories: the conjugative, non-conjugative, stringent, and relaxed. Conjugative means if set of vectors carrying a transfer gene, if that undergoes a conjugative conjugation process, it is known as conjugative plasmids. If such genes is not undergoing conjugation process, then it is known as non-conjugative. Then while taking a limit copy numbers in a presence in limited numbers, then it is known as stringent plasmids. And if it takes in large copy numbers, it's known as stringent plasmids. In examples of plasmid vectors, there are a major one is PBR 322 and others are 325 and so many, so their presence in nowadays. In the PBR is there are presence of nomenclature, that is P means the plasmids and P and R is denotes scientist names that are discovered by the scientists Bolivar and Rodriguez, and their designated number that is 322. In PBR 322, there are various sites, that is the origin of replications and selective markers and site of cloning. In the origin of replication is the main site, that is also known as ovary site, where the replications starts from here. Then selective markers, that is ampicillin resistant genes and tetracycline resistant genes. Ampicillin is antibiotics, then it will reduce the growth of bacteria, but here it's used as a the selective markers, that is the vector is working or not to determine the work of the vectors. Here ampicillin resistant genes are working. That is, if the presence of ampicillin resistant genes, we can check whether the bacteria growth is or not. Then site of cloning, where the cloning is takes place. Then next is a bacteriophage. Bacteriophage is simply known as a phage or a virus that replicate within the bacteria. It won't replicate within virus. Okay. Then advantage is it can take up larger fragments of DNA when compared to plasmids. It's a main advantage. An example, phage lambda and phage M13. In a phage, bacteriophage, in phage lamella is the structure of the phage lamella. It contains a head, collar, and tail. In a head, there will be presence of a DNA molecules, DNA fragments. It the vectors is contain foreign DNA fragments. It undergoes after insert into bacteria or host cell. It undergoes two cycles, that is a lytic cycle and a lysogenic cycle. The major difference between the lytic and lysogenic are in a lysogenic cycle, the viral DNA integrates within bacterial DNA, that is combined with the host cell DNA. It undergoes its production and it will produce its own DNA fragments. But in lytic cycle, it remains separate in a cell and it undergoes its replication process and produce its own DNA fragments, and it undergoes further it undergoes lytic cycle and lysogenic cycles. Then another vector is cosmids. Its major point is it contains the characteristics of both plasmids and bacteriophage lambda. That it contains characteristics of both plasmid vectors and bacteriophage vectors by using of the enzymes, that is a cutting enzyme and a pasting enzyme, that is restriction endonuclease is a cutting enzyme and the DNA ligase is a pasting enzyme. Further fragments of plasmid vectors and bacteriophages are used. Another example for cosmids are passive vectors. In artificial chromosome vectors, it is further divided into human artificial chromosomes and yeast artificial chromosomes and bacterial artificial chromosomes. Here, it is in human, it is a synthetically produced vector DNA possessing characteristics of human chromosome, and it also size range is similar to human chromosome, that is 1/10 to 1/5 of the human chromosome. and it is considered as a self-replicating microchromosomes. Each artificial chromosome is a synthetic DNA that can accept large fragments of foreign DNA, and it is known as the largest capacity vectors due to it contains a large space to carry a foreign DNA molecules. Then bacterial artificial chromosomes, it can avoid the instability of yeast artificial chromosomes. It's due to this main advantage is using bacterial artificial chromosomes. Then at last, shuttle vectors. Shuttle vectors is it can grow in two different hosts, that is E. coli or Streptomyces species. First of all, it replicates in one host, either E. coli or Streptomyces, then it further transfer into or shifted into another host, then it continues its replication. Well, so many vectors are present nowadays. Then we need to select according to the characteristics of the vectors, that is the choice of vectors. Then by seeing size of foreign DNA, efficiency of the process, then size of inserting DNA, we need to select the vectors according to this. Thank you.
Yeah, very good afternoon to everyone present here. Today we are going to see about the progestin, which is presented by Vignesh V. The progestin, these are the substances which convert the estrogen prime proliferative endometrium to secretory and maintain pregnancy in animals paid after consumption. The progestin, which is favoring pregnancy, there are two types: natural progestin and synthetic progestin. From the category of natural progestin, we have 21 carbon steroids, which is produced in the corpus luteum, and then we having a synthetic progestin, which was classified by two types: progestin derivatives and 19 not testosterone derivatives. We have the progestin derivatives, we have some examples: egesterol acetate, and then 19 not testosterone derivatives, we have levonorgestrel and norgestrel. After that, we are going to see about the pharmacological actions of the progestin. We have uterus, cervix, vagina, breast, CNS, and body temperature, respiration, and metabolism. On that, we have saying about uterus. Uterus, the progesterone brings about the desirable changes in the estrogen prime endometrium, hyperemia, toxicity of the gland, increased secretion occurs while epithelial proliferation is halted. It lacks progesterone support, which causes mucosal shedding during menstruation. Continuous action of the progesterone brings about desirable changes in the endometrium, stoma enlarges and becomes spongy, gland atrophy, and sensitivity of the myometrium to oxytocins decreases. Cervix. The progesterone converts the watery cervical secretion induced by the estrogen to viscid, scanty cellular secretion, which is hostile to sperm penetration, which is cervix, the progesterone acts as a contraceptive action. The vagina, the progesterone induced pregnancy-like changes in the vaginal mucosa, leukocyte infiltration of cornified epithelium occurs. The breast, the progesterone causes proliferation of acne in the mammary gland. It prepares the breast for lactation. Withdrawal of this hormone after delivery causes release of prolactin from pituitary, and milk secretion occurs. After that, we are going to say about the CNS, central nervous system. High circulating concentration of the progesterone during pregnancy appears to have a sedative effect. It also affects the mood, the body temperature, and then a slight 0.5 degree rise in temperature by resetting the hypothalamic thermostat, which is nothing but the hypothalamus, which is nothing but a temperature regulating center in our body. An increase in heat production is induced. This is responsible for higher body temperature seen during the luteal phase. We have three phases in the menstrual cycle: follicular phase, ovulatory phase, and luteal phase. Luteal phase, the progesterone hormones are secreted in the presence of luteinizing hormone. Respiration, we are going to discuss about respiration. The progesterone in relatively higher dose of stimulates respiration as occurs during pregnancy. Next, we are going to discuss about metabolism. Prolonged use of oral contraceptives impairs glucose tolerance in some women. If, for example, megestrol acetate, levonorgestrel, for prolonged use of oral contraceptives causes glucose tolerance some movements. Progestin, especially with the androgenic activity, 19 non-testosterone derivatives tend to rise low-density lipoprotein and high-density lipoprotein cholesterol levels. Next, we are going to see about pituitary. The progesterone is a weak inhibitor of GN secretion from pituitary. It exerts a negative feedback primarily at the level of hypothalamus pulse generator, reducing the frequency of GnRH pulses. And then uses of the progesterone, it acts as a contraceptive. If, for example, megestrol and levonorgestrel as examples of contraceptives, hormone replacement therapy, and dysfunctional uterine bleeding, the progesterone generally large doses are used for the to stop the uterine bleeding and endometriosis, premenstrual syndrome. In premenstrual syndrome, headache and breast tenderness are some of the cases seen in some women. So, for that purpose, progesterone are administered habitual and threatening abortion and endometrial carcinoma. In endometrial carcinoma, the 50% of the endometrial carcinoma are treated by a large dose of progesterone. Thank you.
Good afternoon. Good afternoon, everyone. My name is Esther. I am here to present about drug interaction. Before going to the topic, what is drug interaction? Drug interaction is a process in which when the two drugs are given together, there is a alteration in the activities which may result in either the synergetic activity on the other drug or antagonistic effect on the other. The content of my presentation was the introduction, result of drug interactions, reasons, pharmacokinetic interactions, pharmacodynamic interactions, garlic and the ADR uses and the interactions. First, what is drug interaction? Herbal drug mixed with given with allopathic drugs will result in some reactions. That means when the herbal medicines and the allopathic drugs are administered together, which will result in a change in pharmacokinetic and pharmacodynamic properties. The herbs are the main reasons for this type of interactions. Moreover, the herbs are widely used because of its availability, economic consideration, and its safety. The herbal drugs, herb with drugs interactions leads to pharmacokinetic and pharmacodynamic and pharmaceutical changes. The pharmacokinetic changes are the change in the absorption, distribution, metabolism, and excretion of the drugs, thereby change in the level of drug in the blood. And pharmacodynamic changes are which will result in additive, synergetic, antagonistic, or unidentified response. The reasons begins the herb drug interactions are due to the lack of adequate knowledge and no quality control and quality assurance for the purity and safety of herbal drugs, and no advanced research in the field of herbal drugs, and mythological belief of Ayurvedic drugs and adulteration of herbal drugs are the reasons for which the herb drug interactions will occur. The pharmacokinetic interactions are whenever the drugs are taken along with ginger, green tea, black pepper, etc., will increases the absorption of the drug, whereas the fibers and mucilage herbs can decrease the absorption of the drugs. Metabolism, the metabolism can be increased by the means of Google, whereas the grape juice will decrease the metabolism because the grape juice are inhibit the cytochrome P450 enzymes, and the elimination process can be increased by laxative diuretics, especially aloe can increases the elimination, whereas the licorice can reduces the elimination. And pharmacodynamic interactions, additive effect is anticoagulant with the ginkgo biloba will result in additive effect, whereas the antidiabetic with the Gymnema species can produce synergetic effect, whereas the antagonistic effect is seen when the procyclidins are given along with the anticholinergic drugs. And garlic, the synonym, the garlic is garlic and allium. It is obtained from the bulb of Allium sativum of family Liliaceae. The active constituents are carbohydrate present at 59%, proteins 50%, and volatile oils 20.5 to 10%, among which the active constituent sulfur containing volatile compound allene and allicin. Apart from this, it also contains glycosides, monoterpenates, enzymes, vitamins, and minerals. It is used as a stimulant, carbonative, disinfectant in pulmonary disease, and it will prevent Alzheimer's disease at high dose. It can reduce the blood pressure and maintain the cholesterol level. And allicin, which is a sulfur-containing molecular compound, which is responsible for antibacterial activity, and the oil obtained from the garlic is used as an anti-emetic and rubefacin, and fresh garlic is used in the prevention or prophylaxis of amoebic dysentery. And side effects are heartburn, acid reflux, bad odor, and diarrhea. Interactions, it can mainly interacted with anticoagulant, especially warfarin. Thereby, these anticoagulants are generally used to stop the bleeding. If they are taken along with the garlic, it will increases the bleeding. Interact with the ACE inhibitors like capryls. Here, the pills are given to reduce the blood pressure, but the garlic along with the pills will reduces the blood pressure too much, hence the person undergo hypotension and decrease the absorption of the drugs, and it will lead to hepatotoxicity and interact with the protease inhibitor, especially sacunovir, in which when the garlic is given along with the sacunovir, it will reduces the blood cholesterol level. And thank you.
So, a very good afternoon to all the participants and the presenters. So myself, Dr. Habib, I would like to give a small analysis of the last 4 presentation what just we heard. I will give my feedback about the 4 presentation, then after that, I add up some of the points what can be incorporated for improvising the presentation skills and the techniques what that can be used. So the first presentation made by Pradiksha on the recombinant technology. So mostly it has been observed only the pictures has been displayed in all the slides. So the text content were been missing, and it looks like the read out content only by the pictures. So there is some kind of animation can be incorporated along with the text, some bold informations about the slides. So when you look at the E. coli on the first slide as a history, they can be incorporated what is E. coli and a few informations. So if that would have been incorporated along with the pictures of minimal content, text content also incorporated, means it would have been made better for the audience to understand what the presentation is talking about. Then the second presentation about the cloning vectors. So while compared to the first and second presentation has filled with more of text rather than the images what has been presented. So then voice variety, as the first speaker mentioned about the 7 ideas about for good presentation. So how far you are pitching your information that can be incorporated. So the second presentation, there has been more text rather than the images. Then the third presentation, the progestin, about the progestin also. So there has been some text and there is no much images has been presented. So I'll compare the second and third presentation look similar with the text content, and the voice variation can be much improved. Then the fourth presentation is a mixture of images along with some kind of a text informations, and the presentation is a bit faster while compared to from my view, the presentation looks a bit faster. So then these are the little feedback about the 4 presentations. So here, what I want to say to the presenter and along with the participants can take some note of my points, what the presentation has to look like. So generally, we follow 5x5 rule in presentation slide preparations. So you cannot go more than 5 words in a line and not more than 5 lines. So that is the basic thumb rule of any presentation. And now the recently technology, the PowerPoint itself has been improvised a lot. So it become more user friendly while compared to the previous year PowerPoint presentation preparations. So you can use all the tools which is available in your PowerPoint. You can use more text, means you understand the audience to whom you are talking. Then you incorporate some kind of animation to attract the audience. So make the audience to go along with the presentation slides. So like what the Dr. Maladi Madam has mentioned, that how you can move along your ideas. So one idea in a slide. So like that, you have to make your audience to be with your presentation content so that you can make a good, impressive presentation. So these are some of the points. So here these presenters can incorporate these things to improvise their presentation skills. Thank you.
Good afternoon to everyone. I'm Amsavalli. I'm going to present about natural remedies for asthma. First, we will see about what is asthma. Asthma is a common chronic inflammatory disease of the airways characterized by variable and recurring symptoms, reversible airflow obstruction, and bronchospasm. Common symptoms for asthma is wheezing, cough, chest tightness, and shortness of breath. Symptoms are usually worse at night and in the early morning or in response to exercise or cold air. Causes of asthma. There are two types of factors involved in that. First, we will see about environmental factors, allergens, air pollution, and other environmental chemicals which causing asthma. Smoking during pregnancy and after delivery is associated with a greater risk of asthma-like symptoms. Low air quality from factors such as traffic pollution, exposure to indoor volatile organic compounds, and indoor allergens such as dust mites, animal dander, and mold. Next, we will see about the genetic factor. Family history is a risk factor for the asthma, with many different genes being implicated. If one identical twin is affected, the probability of the other having the disease is approximately 25%. 25 genes had been associated with asthma. Next, we will move on the pathology of asthma. Trigger factor which leads to the airway inflammation, which causes hypersecretion of mucus, air muscle contraction, swelling of bronchial membranes, which leads to the narrow of breathing passages, which causes wheezing, cough, shortness of breath, tightness in chest. Next, we will move on the natural remedies for asthma. First, we will see about the garlic. Raw garlic can promote histamine breakdown and reduce histamine release in the body. Garlic can increase the ability of the body to create prostacyclins. Prostacyclins are lipid molecules that help keep the air passages of the lung open and thus promote easy breathing in asthmatic individuals. Next, we will move on the turmeric. The main constituents in turmeric responsible for its medicinal property is called curcumin. Anti-inflammatory properties due to largely curcumin's ability to inhibit enzyme involved in the process of inflammation. Next, we will move on the peppermint. Peppermint oil might help to reduce the asthmatic effect on the airways to make breathing easier. Next is lemon. Lemon have certain properties that can make them effective at fighting asthma. Since lemons can help to reduce the effect of asthma triggers on the lungs and also help to reduce the inflammation and mucus, they could be considered an effective natural remedy for the disease. Next is ginger. Its asthma fighting properties are thought to be attributable to ginger oils, strong anti-inflammatory substance that also give ginger its distinct flavor. Fresh ginger, which is said to be the most effective form of ginger. Next is the honey. It's believed that the sweetness of the honey triggers your salivary glands to produce more saliva. This may be lubricate your airways and easing for the cough. Honey may also reduce the inflammation in the bronchial tubes and help to break the mucus that is making it harder for your breath. Next is the anise. It contains compounds known as cresol and alpha-pinene. These natural compounds help to loosen the bronchial secretion, making it easier to expectorate them. Bronchial secretion are common cause of bronchial obstructions, as too much of secretions in the bronchus can prevent the air from flowing in, lead to asthmatic attacks. Next is the coffee. Caffeine is a mild natural antihistamine. It is similar to the theophylline that was commonly used to control the asthma before more effective treatment were discovered. Research shows that 2 cups of strong coffee taken during an asthmatic attack can significantly reduce the symptoms as the bronchial tubes open more and breathing easier. And final one is the licorice. It contains glycyrrhizin and antioxidants. The roots of the licorice improve the breathing pattern by dilating the bronchus and decrease the production of mucus. People with allergic reactions to the corticosteroid can use the wild licorice root. Thank you.
A warm good afternoon to one all present here. Today, the topic for presentation is hypolipidemic drugs. First of all, we'll look at what are lipoproteins. The plasma lipoproteins are the chylomicrons, low density lipoproteins, intermediate density lipoproteins, and very low density lipoproteins, high density lipoproteins. So the hyperlipoproteinemia occurs when the level of lipoproteins occurs and exceed the normal lipid levels. So let's look at the drugs which are used for the hyperlipidemia. So first category is HMG-CoA reductase inhibitors. This consists of lovastatin, simvastatin, pravastatin, atorvastatin. And the second category is bile acid sequestrants. This contains cholestyramine and cholestyramine. Third category is lipoprotein lipase activators, which consist of clofibrate, gemifibrozil, bezafibrate, fenofibrate. And the fourth category is lipolysis and triglyceride synthesis inhibitors, which is nicotinic acid. And the last category is sterol absorption inhibitor, which is estimate. Today, we'll see about the 3 categories: HMG-CoA inhibitors, bile acid sequestrants, and cholesterol absorption inhibitors. The first category, which is HMG-CoA reduction inhibitors, inhibit the HMG-CoA reductase enzyme, which is responsible for the conversion of HMG-CoA to mevalonate. This results in the decrease in the low density lipoprotein and very low density lipoproteins and increase the HDL levels in plasma. When we look at the dosage forms, it is given usually once daily in evening. The adverse effects are hepatotoxicity, headache, and myopathy. The second category is bile acid sequestrants. These are the resins which bind to the bile acids in the gut and interrupt their enterohepatic circulations. Thus, it promotes the conversion of cholesterol to the bile acids in the liver. It also helps in to stimulate the formation of hepatic low-density lipoprotein receptors, which takes up more lipoprotein cholesterol from the circulation. In case of ADR, it has no systemic adverse effect, but it has bloating and nausea. The last category is cholesterol absorption inhibitors. It inhibits the absorption of dietary and biliary cholesterol in the intestines. It reduces the low-density lipoprotein cholesterol, and it is usually given along with a combination with statins. This combination produces an addict effect in low-density lipoprotein cholesterol levels. The only ADR known as hepatic dysfunction. Thank you.
Happy greetings to all listeners. I am Yashwant, here to present our topic of production of penicillin. Before going into the topic, we need to revise some of the terms relating to the topics. One of the main terms is that antibiotic. What are antibiotics? Antibiotics are the class of antimicrobial agents which are used to prevent or in the treatment of bacterial infections. These are also used as prophylaxis for bacterial infections. Then fermentation. Fermentation, it is the process which involves enzymes to convert or make any chemical changes in the organic substrates. Then fermenter. Fermenter are the instruments which are used in the process of fermentation. These are also known as bioreactors. First, penicillins. What are penicillins? These are beta-lactam antibiotics. These are called beta-lactam antibiotics because these consist of a beta-lactam ring in their structure. Then these are the first discovered antibiotics. These are the major part of the antibiotic discovery. Then these are active against both gram-positive and gram-negative organisms. The mechanism of action of penicillin is that it interferes with the cell wall synthesis and inhibits it. Now, organisms used in the production of penicillin. The penicillins were first isolated from Penicillium notatum. These were used as the organisms for production in the early stages. But currently, many genetical modifications were made and new organisms were discovered. Currently in use is Penicillium chrysogenum. The Penicillium chrysogenum is also seeing many improved mutant strains. For example, introduction of enzyme cyclase. This cyclase enzyme is useful for breaking down of hydrogen peroxide. Then these are the high yielding strains. Some of the high yielding strains are Q176, NRRL 1951. Then inoculum preparations. Before getting the organisms into the inoculum tank, the spores of stocked spore-related species were collected and converted into nutrient solution. The concentration was 5 into 10 to the power of 3 spores per ml. Then incubation period is 5 to 7 days at 24 degrees Celsius. The resulting spores are then converted to inoculum tank. Yes, these are the general requirements for penicillin production. First, the fermenter used. It is stirred tank fermenter. Stirred tank fermenter is used for the fermentation process. Deep tank fermenter. Deep tank fermentation is nothing but it uses stirrers and oxygen supplies. The penicillin production involves aerobic fermentation. Then aeration rate required is 0.5 to 1 ppm. Then the required pH for penicillin production is 7 to 7.5. The optimal temperature is 25 to 27 degrees Celsius. Then the media preparation. The media majorly consists of corn steep liquor. The corn steep liquor is obtained from corn bed milling, which is the process of separating corn. Then the carbon sources were lactose and glucose. Then calcium or potassium carbonate is used. These are used for maintenance of pH. These are buffers. Then edible oil is used. The various edible oils used in the preparation of penicillin are lard or linseed oil. These are used as anti-foaming agents. Then production. First, the constant liquor has the pH of 5. During this pH, the ammonia will be liberated, which rises the pH from 5 to 7 or 7.5. This pH 7 or 7.5 is the optimum pH for the penicillin production. Then the pH is maintained by use of calcium carbonate or potassium carbonate. Then at first 20 to 30 hours, only the fungal growth will be there and it will be thick and so heavy. To prevent the formation of foam, lard or linseed oils are used. Then the duration for the total production of penicillin will be 48 to maximum 96 hours. The maximum yield which can be yielded is 1,500 units per ml. Then the major part of the penicillin production or any other antibiotic production through fermentation process is downstream process. The downstream process of penicillin should take place before the pH rises to 8. If the pH rises above 8, it will lead to the degradation of penicillin that is produced. Then the solids and mycelium are removed through rotary vacuum filter. Then the penicillin is separated from or isolated from the other solutions through solvent extraction method. The solvents used for this method is butyl acetate or amyl acetate. The temperature for this extraction is 10 degree and the pH required is less than 3. Then activated carbon is used, which is used for removal of impurities. Then potassium or sodium hydroxide salts are used. These are used for formation of penicillium salts. Then dry solvents are used for removing any other impurities that may be present along with our product. The examples of dry solvents are N-butanol or isopropanol. Then the final process is that waste disposal. The aqueous extracts, which is used for the isolation of penicillin, will be discharged to sanitary sewage. Before discharging to the sanitary sewage, it should undergo municipal waste treatment. Then the liquids which are used may be evaporated or heated to dryness. Then solids. These solids are buried under deep ground. Nowadays, the mycelium are used for making construction bricks, which is displayed in the picture. Thank you for listening.
Good afternoon, I'm not present here. This is Monica here to present about the blotting technique, sudden blotting. So let's see what is blotting first. Blotting is a method of transferring proteins, DNA or RNA into a carrier, which usually follows gel electrophoresis. This blotting technique can be classified as northern blotting, southern blotting, and western blotting. In northern blotting, we used to detect RNA. In southern blotting, we detect DNA, and in western blotting, we detect proteins. So let's see what is sudden blotting. It is a method used to detect specific DNA sequence in DNA samples. It is usually done by gel electrophoresis. It is named after its inventor, Edwin Mellers-Sudden. So the principle behind sudden blotting is hybridization. Hybridization is nothing but joining two single-strand DNAs to form double-stranded DNA. So where one strand is our target DNA and the another strand is probe DNA. So the two important features of this hybridization is they are reaction specific. The probe only binds to the complementary sequence of target DNA. The probe can find its target even in mixture of millions of non-complementary molecules. This is the advantage of this. So the steps involved in sudden blotting are first extraction and purification of DNA, and DNA is restricted with enzymes and then separated by electrophoresis, and then it follows denaturation and transfer to nitrocellulose paper and addition of labeled probes, washing and autoradiography. The first step is DNA extraction. The cells are lysed using a detergent that disrupts the plasma membrane. The cell contains all proteins, DNA and RNA. So we only require DNA. So the DNA is collected by adding RNAs and protease, which will destroy protein and RNA. So the now cell debris only contains DNA, which can be precipitated and centrifuged and taken out. The second step is restriction of DNA. So the DNA is long, so it is restricted using restriction enzymes like ECOR1, and it is fragmented. The third step is gel electrophoresis. It is usually done by taking a glass plate where agarose gel is poured and a comb is used to push down and wells are formed where the DNA is put, and the DNA fragments are moved using voltage where the DNA will be moved from the negative charge to the positive charge. Here, the DNA is separated into their sizes. This movement can be viewed by using epidemium bromide dye. And the fourth step is denaturation. So the restriction fragments present in the gels are denaturated with alkali. This makes the double-stranded DNA to single-stranded DNA. Then the DNA is neutralized with sodium chloride to prevent the rehybridization. So the fifth step is transfer to nitrocellulose paper. So the DNA is transferred from the gel to solid support. So the buffer below is moved above by capillary action. Then it is dried at 80 degrees Celsius. So the sixth step is addition of labeled probes. The filter is incubated under hybridization condition with specific radio-labeled DNA probe. The probe hybridized to complementary DNA restriction fragment. The seventh step is washing. It is washed using buffers like sodium chloride and detergent, which will wash away the excess of probes and background. So the 8th step is autoradiograph. The probe is radioactive. Thus particles emit when exposed to X-ray film. There will be dark spots on film where the probe is bound. So this is the whole step pictorial representation of southern blotting. So next are the advantages of southern blotting is it is an effective way to detect specific DNA sequence in large and complex sample of DNA. It is used to quantify the amount of DNA. The disadvantages is it is more expensive and time consuming. The applications of southern blotting is it is used to identify specific DNA in DNA samples to isolate the DNA from construction of our DNA. So it can identify mutation, deletion, gene rearrangement. It's used in gene discovering, mapping, and it is used as a diagnostic tool in disease like cancer, HIV, and is used in DNA fingerprinting for paternity and maternity testing, criminal identification, and for personal identification. Thank you.
Good evening, everybody. Good afternoon once again to all the delegates present over virtually. I'm really happy that I'm here to analyze and suggest some of the points to the presenters. So I really appreciate all the participants who took their time to present their slides here. I appreciate Ms. Amsavalli, Vishnu Ajit, Ashwin, and Ms. Monica for their presentation. I would like to suggest few things to their presentation slides. First, Amsavalli, who presented on pathology. The images was appropriate in her slides, but the thing is that there are too much of content in one slide which can be reduced to engage the audience more. And whereas with Mr. Vishnu Ajit, he has more of text in his slides, and he can include more of infographics which can engage the audience more into his sessions. And I really appreciate him for his voice inflections which can engage the audience effectively. And Mr. Ashwin, the very good thing about Ashwin's presentation is he has given some introduction to some of the common points. So the audience who may be new to the topic will also be engaged in that one. And Ms. Monica, who talked about the presentation on blotting, her presentation slides was a proper proportion of image and content, and which was really appreciable. And I would like to add few more points which will making effective presentations. In general, the more to start with an effective presentation, a very effective introduction is what all needed for the thing, for a gripping presentation. So I request all the presenters and the participants to start with a gripping introduction on the topic and give a small story or anything linked to that particular research topic. And second thing I would like to emphasize is that the participants should have an enthusiastic show over their voice, which should be infectious to the participants also. And when you're transiting from one slide to another slide, you should have a good connective words. You can avoid some filling words like blah, ha, or that. So it will engage the audience more towards one. And finally, the effective conclusion is what all I needed to a good presentation. So we always try to, as told by Ms. Dr. Malati, we should always re-emphasize some important points in the presentation, because when the audience is sitting there for more than 1 hour, they will not be attentive for all the 1 hour. So we need to re-emphasize some of the important points, and we need to give an effective conclusion, which should be a take-home message for all the participants. So herewith I will conclude my session, and thank you for giving an opportunity. Thank you.
I thank Dr. Habibur Rahman, Dr. S. Malati, Mrs. R. Nitya for commenting over the presentation given by the participants. Thank you, sir and ma'am. Dear audience, today's session comes to an end, and last day of CPE program, 5th day, we'll meet by 10 o'clock tomorrow. Thank you all.